Okay, so you guys want to find the handouts that said 8.4 on the top. Okay, and we're just going to look at this one problem right here. So you might have to pause the video to get that up and going. But, yeah, so, and unpause when you're ready, obviously. Okay, so this first one, I want to graph this function. Now, I want you to recognize that the function is in vertex form. Okay, and we know that the vertex is going to go 2 to the right, up 6. So I know that the vertex is right there. I know it's opening down because of the negative, and then 1/2 affects the y values. So normally I would go over 1 down 1, but I'm going to go over 1 down 1/2. Okay, and then I would go over 2 down 4, so I'm going to go over 2 down 2. Let's see, over 3, we would be at 3 squared is 9. So 1, 2, 3, 1, 2, 3, 4 1/2. 1, 2, 3, 1, 2. Okay, so I think that'll pretty much give us a good idea. Okay. Now find the value. So they want the area under the curve from 0 to 5. Okay. So let's say 0 to 5 of f of x. And I can just write f of x right there since f of x is written right up here. Okay, so this is going to be negative 1/6 x minus 2 cubed plus 6x from 0 to 5. Okay, and then I got negative 27/6 plus 30. And that is my area. Okay, and we are going to shade this region blue. Okay, so I only went from 0 to 5. So I'm going to do it kind of light colored. Okay. Gotta be perfect. All right. Now we're going to draw this function. Well, this is just a linear equation written backwards. Negative 1/2 x plus 4. Okay, so there, and the slope is down 1 over 2, down 1 over 2. Looks like I can see it in there. Okay, and we're going to do the same thing. So this is g of x right here, and this is f of x. So we're going to find in part, what is it, E, the area under g of x. Okay, so that is from 0 to 5 of g of x dx. And that will just be 4x minus 1/4 x squared, 5 to 0, 20 minus 25 fourths minus 0. It's going to give me 55 fourths. Okay. Now they want us to shade that region green. Okay, so that was this right in here. Okay, now how would you find the area of the region that lies between the two graphs? So this little light blue area right here. Well, hopefully you would say, well, I could take the area of the whole thing and subtract off the green part, and I would be left with the area of the blue part. Okay, so we're going to say from 0 to 5, f of x dx minus 0 to 5 g of x dx. And we could just subtract those areas, which I didn't do yet, and we would have the area in that final region right there. Okay, okay, so we're going to move up to example 4. We're going to go back to example 3, but we're going to do them on separate days. Okay, so let's look at something a little bit more complicated, where we have these two functions, f of x and g of x. So let's see, g of x is the quadratic, so that's g of x, and that's f of x. And we want the area between the two graphs. So I'm looking for the area in here, but notice that it's kind of interesting thing happens is that f of x is not on the top the whole time. That over here, I would have to do g of x minus f of x to get this area. And over here, I would have to do f of x minus g of x. Okay, so that's not too hard. What you're going to do first is you're going to just find the intersection of the two curves. And we have to prove it. We can't just use our graph. So I'm just going to write 14x plus x squared minus 2x cubed equals x squared minus 4x. Okay, so let's see. Those are going to cancel out. I'm going to get 18x minus 2x cubed equals 0. I'm going to take out my GCF. Okay, got to set each piece equal to 0. Okay, so 2x equals 0, which means x is 0. This is going to be 3 plus x, 3 minus x equals 0. So x equals negative 3 and positive 3. Okay, and we can see, since we have the graph, that that is exactly where they're crossing. Okay, so I'm going to have to take that into account when I set up these integrals. Okay, so that's the second part. Okay, we're going to set those up, and we're going to calculate the area. Okay, so I'm going to do from negative 3, because that's where they're going to cross, over to 0. So the interval from negative 3 to 0. And remember, g of x is on top this time. So I'm going to say of g of x minus f of x dx plus the area from 0 to positive 3. But now g of x, or excuse me, f of x is on top. So I'm going to go f of x minus g of x dx. Okay, and I'll just simplify it a little bit here. We end up getting something like 2x cubed minus 18x dx 0 to 3 of negative 2x cubed plus 18x dx. I just did those both on my calculator, and I got 40.5 plus 40.5. And the area is 81. Okay, so again, not too bad. You just have to remember, like, if you don't have a picture, that you're going to have to think about this. Do these things cross? Which one's on top? Which one's on the bottom? Okay, and then the last one that we'll do on this video, because we're running out of time, maybe I'll make a new video. Okay, bye.